there! My name's Aminta and I work for Cobb County Water System, and I've got a question for you. What was one thing that you used water for today? Did you wash your hands, use the toilet, or even drink some water? Think of all the different ways we use water for today. If you add it all up, that's a lot of uses. We use water to drink, to clean, and my favorite, to have fun. And that's just you and me. What about our whole neighborhood, our whole community in Cobb County?
How do so many people keep using water every day and have enough clean water for tomorrow?
Water is a limited resource, meaning we have the same amount of water since the dinosaurs roamed the planet. We can't make new water or more water whenever we need to. We have to work with what we have right now. So instead, we treat the water so that we can use it for years and years to come. Let's see how the water we use is cleaned, not just for our community, but for the plants and animals too. Welcome to Cobb County Water System's Northwest Water Reclamation Facility. This place gets its name because it treats wastewater in the northwest area of Cobb County, including cities like Acworth and Kennesaw. We call it a reclamation facility because we are reclaiming or restoring the wastewater to what it once was, water in a stream. Do you know what wastewater is? Wastewater is whatever that goes down the drain after you are done using some water. After it goes down a drain, wastewater travels to a reclamation facility like this one. And the Northwest Water Reclamation Facility treats up to 12 million gallons of raw wastewater per day. That's enough to fill the largest tank at the Georgia Aquarium, not once, twice. That's a lot of wastewater. Well, guess what? Northwest is actually the smallest of the 4 treatment facilities here in Cobb County.
The largest facility in Cobb County, Sutton Water Reclamation Facility, can process up to 60 million gallons of raw wastewater per day, or in other words, enough to fill the Georgia Aquarium's largest tank 10 times.
Wow! Now back to Northwest. Pipes connected to toilets, sinks, bathtubs, and showers bring water to larger collection pipes underground.
This network is over 2,600 miles long. That is the same distance it would take to drive across the country from Atlanta, Georgia, all the way to Portland, Oregon.
Wastewater from the northwest area of Cobb County will eventually arrive at the Proctor Creek Pump Station, just 3/4 of a mile away from here. Now, pump stations push wastewater using the force of engines, and it gives it enough force to travel all the way here to Northwest. As wastewater is pumped through the screens, they let wastewater go through and stop large objects like rags and plastics from traveling any further. To discover why, let's head to the lab for an experiment. Welcome to Cobb County Water System's studio, where we are gearing up for a fun lab experiment. Are you ready? I have in front of me 2 beakers filled with plain old water, and I am going to be adding toilet paper into this one. Oop. And in this beaker, I will be adding a flushable wipe. In just a moment, I'm going to do some movie magic and speed up the time so you can start seeing some interesting changes. As you're making your observations, I want you to think about the answers to these key questions. Which one do you think looks more dissolved? Do you think it's the toilet paper or is it the flushable wipe? Are you ready? Let's go! From what you saw, do you think that the flushable wipe should be flushed down the toilet? No, so disposable wipes, even those that say they are flushable, never fully break down like toilet paper does. Who would have thought? They belong in the trash. Your toilet is not a trash can. Only the 3 P's should be flushed down: poop, pee, and toilet paper. Physical bar screens early on in the wastewater treatment process help remove rags, an all-encompassing term that not just includes disposable wipes, but also paper towels and even cloth rags like dish towels, other items that should not be flushed down the toilet. Too many of these rags flushed down the toilet can cause pretty gross clogs and flooding, as you can see here. Not much room for water, right? Too many things clogging our pipes can even cause them to break, both here and at your home. So remember, no wipes in pipes. After the wastewater passes through the screens, the physical barriers at Proctor Creek Pump Station, 4 pumps push water all the way to Northwest Wastewater Reclamation Facility, where it finally begins its treatment process at the equalization basins, where the grit chambers are also located. Let's head back to the facility to learn more.
Yup, you heard me, grit chambers. No, not that grit. Over here, grit chambers means granular debris, things like coffee grounds, seeds, and eggshells. Here in these chambers, they settle to the bottom where they are hauled up and out of the way by a machine, just as if you were pulling up a bucket with a chain or a rope. Now, these finer pieces of grit, just like the rags and plastic from earlier, need to be removed now to help protect the pipes and equipment from being damaged. With much of the grit now removed, wastewater flows into what's known as the equalization basins. There are 4 of these equalization basins here at Northwest, and there are that many for a reason: to help control the flow. When do you use water the most? If you said before you go to school or before you go to bed, you are absolutely correct. During weekday mornings, as people are getting ready for work or school, is one of those times. And storing some of the wastewater in the equalization basins helps to even out the incoming flow to the facility. In addition to physical treatment, which uses physical barriers like screens to clean the water, wastewater is also cleaned using chemical treatment steps as well. Have you heard of the term mixture before? A mixture is a combination of at least 2 different substances with chemical properties that are not the same. Wastewater is a great example of a mixture because it contains solids, liquids, and sometimes even gases. A liquid chemical is added to wastewater, and that chemical helps tiny minerals clump together so that they can be removed from the wastewater more easily. Let's take a closer look to find out just how they are removed. Look at these cylinders. This is where primary treatment takes place. These tanks span 70 feet in diameter. They're called primary clarifiers, and they help to separate two things from the wastewater: scum and primary sludge. Scum consists of fats, oils, and grease particles that float on the surface, and these are swept off by the primary clarifier's slowly spinning arm. Primary sludge, on the other hand, consists of more dense contaminants like heavy metals that are heavier than water and so settle to the bottom. Another chemical treatment step also begins at these primary clarifiers. Do you see that big building over there in the back that's really tall? That's where we hold a special chemical called lime. That mixes in with the wastewater that's in the clarifier. It's meant to lower the pH, or the acidity, of the wastewater. Have you heard of the term pH before? pH stands for potential of hydrogen, and it's a scale of acidity from 0 to 14. It tells how acidic or alkaline a substance is.
For example, sour juice from a lemon is 2 on the pH scale. The pH of raw wastewater can be slightly acidic. Our drinking water is usually neutral, around 7, in the middle between 0 and 14. Adding some lime is meant to make the pH of the wastewater more neutral. Oh, and by lime, we mean the lime slurry we added to the primary clarifiers, which is made from lime found naturally in limestone. Lime slurry is very alkaline, not to be confused with the fruit lime, which is very sour, like a lemon. Can you guess why we need to make the wastewater more neutral on the pH scale by adding more lime?
Hold on to your hypothesis. Let's move on to the next step to find out. Here at the aeration basins, the start of the secondary treatment process takes place. What if I told you that there's a very important group of water workers that live in the water? Their job is to treat the wastewater biologically, and they're not people, they're bacteria. These are microorganisms, small, tiny living things that can only be seen with the help of a special scientific tool called a microscope. These bacteria gobble up tiny suspended particles of organic matter and turn them into carbon dioxide in water. Now, bacteria work best in large numbers, so we do everything we can to give them all the conditions they need to grow their populations. In other words, we provide them their ideal habitat, which is a natural home that provides an organism with everything that they need to survive.
That's where adding the lime comes in.
Because they love a neutral pH environment. But wait, there's more. In addition to having the right pH level, these hard-working bacteria need oxygen too. See that bubbling activity on the surface of the water?
That is oxygen being pumped into the basins from underwater.
Again, just like fish living in a stream, dissolved oxygen is so necessary for these types of organisms to survive. As wastewater flows out of the aeration basins, another chemical treatment step takes place. But before we move on to the next step, let's see if you've been paying attention with a snap poll. Are you ready?
The question is, as a system, the wastewater treatment process uses which of the following treatment steps? Is it 1, physical treatment, 2, physical and chemical treatment, or 3, physical, biological, and chemical treatment? Pause the video to think of an answer. You can resume the video when you are ready. If you guessed 3, you are correct. Physical, biological, and chemical treatment processes are all used for wastewater treatment. Great job! Let's move on.
Welcome to the secondary clarifiers. They look a lot like the primary clarifiers from before, but they are much wider, coming in at 110 feet in diameter. Wow! And just look at the difference in the water at this point.
These tanks allow the biological solids full of those helpful microorganisms to sink and settle to the bottom. No more oxygen is added at this point, so they stop growing in number. Most of these microorganisms will be returned to the aeration basins, where they'll be used for more biological treatment.
At the sludge holding tanks, sludge is mixed with air before it is pumped into the solids handling process, which literally presses out the water before being transferred off-site, where it will be disposed of at a landfill. And even though the water looks clearer now, we're not finished yet. Let's check out the tertiary treatment steps. Here at the automatic backwash filters, 8 sand filters remove finer particles from the passing liquid stream. They consist of sand and anthracite, a type of coal. If you have a water filter at home that you use for your drinking water, this is the same idea, but on a much larger scale. On that note, while I relax here for just a moment, I think it's time for another snap poll. Are you ready?
The question is, which of these facts about the living things used in biological treatment are true? Is it 1, they are bacteria, 2, they need oxygen to survive, 3, they are microscopic in size, or 4, all of the above? Pause the video to think of an answer. You can resume the video when you are ready. If you guessed number 4, you are right. All of these facts are true. These microscopic bacteria thrive in a habitat with plenty of oxygen. Let's head on over to the next form of tertiary treatment here at Northwest.
As you saw earlier, the water is now already pretty clear to our eyes, but it may still contain microorganisms, some of which, not all, can be disease-causing to humans and aquatic wildlife. Here at the UV station, these pathogenic or disease-causing microorganisms will be sterilized, neutralized, and by that I mean incapable of making us and wildlife sick. But we do this without the use of screens, chemicals, or microorganisms like we did in the previous steps. Well, what is it then? Let's put on our detective caps and investigate.
High-intensity lamps inside this building emit strong rays of light and energy, which neutralize microorganisms in the passing stream. The UV light damages their genetic makeup and their ability to function and reproduce. Ultraviolet light is a special form of electromagnetic radiation between visible light and X-rays.
And because ultraviolet light is a form of light or energy, no added chemicals are needed in this step. We've got another stop to make on this tour. Let's go! Can you hear the sound of the roaring, rushing water? That's because the clean water is being pumped over these cascading steps. And this extra step at the end of the process is important because it adds dissolved oxygen back into the water, which is what fish, crustaceans, and macroinvertebrates need in our streams to survive. The water then gets pumped by a rotating machine called a turbine. through a 7.5-mile long exit point underwater all the way to Lake Allatoona. Seeing is believing. Let's grab a sample and take a closer look. Did you do well on the snap polls? Snap polls are a lot like pop quizzes or tests. They make me a little nervous sometimes, but they're really important to check on how we're doing. Water professionals here at Northwest and laboratory staff at our off-site water quality lab are always testing and retesting to make sure every step at this facility follows the rules. They check, for instance, the types and numbers of the different microorganisms growing in the aeration basins, ensure certain chemical levels and pH levels fall within an acceptable range, and a whole lot more. Our wastewater professionals do all this testing with a lot of help from TSG, our technology support group. High-tech sensors are hooked up to just about every important part of the treatment process, and that data is streamlined into a computer program. TSG has customized it so that all of that information and data is clearly shown for operators to see and work from at their desks, much like a control room. TSG also has a big hand in both the physical safety and cybersecurity of our wastewater treatment facilities. By the way, did you see all the pumps and other equipment here? All of that is taken care of and kept in working order by professionals from central maintenance. We need both technology and infrastructure at every treatment step. So the teams of professionals at Central Maintenance, TSG, and the important work that they do make it possible to treat our wastewater. That's it for the tour. That was so much fun. And in it, you learned about the physical, chemical, and biological treatment steps used to clean wastewater before it gets returned to our local streams. Using both science and technology, we are actually speeding up the steps that are found happening in nature so they meet the demand of our large and ever-growing community here in Cobb County. And with that, I want to highlight a really important group of water professionals that help keep this whole operation going. At every wastewater reclamation facility, there are dedicated water operators, technicians, machinists, maintenance staff, buildings and ground staff, and admin specialists, all working together as a team, helping to make sure that this whole system works for us and our environment. So the next time you use water, I hope that you'll think about them. This is Aminta signing off, and remember, only flush the 3 Ps. Have a great day.